We already studied about different phenomena of light which is exhibited in nature. So in this session also we are going to discuss one more optical phenomena exhibited by the light in nature. So that concept is called dispersion. In the previous days, when scientists don't know the reason for the dispersion, it was a matter of debate. The scientists don't know the reason behind the dispersion. So the solution to the dispersion is given by a scientist called Newton. Okay? Then let's see what is this dispersion. What is this optical phenomenon? So after the dispersion, we need to take a glass medium. Here we are taking a prism. We are taking one prism. It's a glass prism. One prism. So what happens is, if a light is incident on this glass prism, see this is an incident ray. When a ray is incident on this prism, the light which was coming out of this prism was consisting of different colors. Okay? The phenomena was when a ray of light is passed through this prism, the light which is coming out of the prism was consisting of different colors. The color was from violet, which is from violet to red. So there were 7 colors was appeared here. That was indigo, blue, green, yellow, orange, red. So there are 7 colors. It is observed when a ray is passed through the prism. These are the 7 colors it was observed when there was coming out of this prism.
This is the animation page to show the dispersion. Here you can see a white light, and that white light should fall on this prism. As it falls on it, and it undergoes refraction, and when the ray is coming out of the other face of the prism, the white light will split into its component colors. See, you can see the colors over here. So this phenomena is called as a dispersion.
So in those days, the scientists don't know the reason behind this. Even this is a very simple one. Still, it was a matter of debate when you look at the history of physics. And the scientists were thinking that why this process is happening. And their thought was whether the light is consisting of all the colors or whether this prism is producing these colors. It was their doubt. They don't know the reason behind this. And their thinking was whether the white light, this is a white light which is coming from the sun. We already know about the electromagnetic spectrum, which consists of different rays, and among which we are only able to see the visible light. And that light is passed through this prism, and after when it passes through the prism, it will undergo refraction because it is entering from air medium into the glass medium. So it undergoes the refraction in this place. Again, the ray is incident on other phase. You can also name this as ABC. On the phase AC, again refraction takes place. After refraction, color it has been split. So So this was the thinking. So this was the thinking of the scientists. So they were not don't know the reason. They were not don't know the exact solution for this. So this is solved by scientist Newton. So he has a very simple experiment. Though it was simple, still there is a lot of significance from this concept. So what was the simple experiment? He placed another prism in a reverse order. Okay, he placed another prism in the reverse order. He placed another prism in this format. He placed another prism. Because of it, what he observed is, again, the light which was coming out of the second prism was white. White light he got that is coming out of the another prism when he placed it in a reverse order to the first prism. So see here the white light is entering into one prism. So the white light is splitting into 7 colors. When the 7 colors are made to pass through the second prism, again he was getting the white light. That's why he came into the conclusion that this prism is not producing any colors. Because once these colors are passed through this, again he was getting this white light. So that he concluded that this white light is consisting of other colors. So that's why whatever the visible ray, what you are getting from the sunlight has 7 colors. So the splitting of light into its component colors. These are the colors. There are 7 colors with giant. So the splitting of light into its component colors is known as dispersion. So this is dispersion, and the Newton's experiment, it is confirmed that white light consists of different colors. White light consists of different colors, and we can say these colors are because of the different wavelengths. Or in other words, each color will have a different wavelengths. If the wavelength being changed, if a ray has a different wavelengths, they will show different colors. So for each color, there is a different wavelengths. Because we already know about the electromagnetic spectrum that these spectrum has the spectrum contains different rays, and all the rays will have different wavelengths, different frequencies. Okay. So we have to question ourselves that why this white is bending more here? White is coming over here, why the red is coming over there? Whether the reverse can happen? No, not at all possible. Always violet will be below the red color. Why this is so? Because we already learned about a factor called refractive index. Young, it is represented as young, which is called refractive index. And refractive index is dependent on the wavelength. Okay, for a different wavelength, there will be different values of refractive index. So here, this is a refractive index of this is a glass which has some refractive index. So this refractive index will be different for the different wavelengths. So refractive index are dependent upon the wavelength. So this refractive index is different for the different wavelength. So that is why I told you all these colors have a different wavelength. So that's why they have a different refractive indices. Sorry, they have a different refractive indices here. So that's why they will bend like this. So this violet, if you consider, if you see here, violet color will bend more, and the red color will bend less. So this is because of the different refractive indices with the wavelengths. So that's why violet will bend more, the red will bend less or least. Okay. So see now, one more thing in terms of frequency and also wavelength we can define. The violet light which has a shorter wavelength. This color violet color has a shorter wavelength. Violet shorter wavelength. There is a very shorter one, that's why it will bend quickly. And red has longer wavelength. That's why it doesn't bend much. See, violet has a shorter wavelength, red has longer wavelength. So if the violet having shorter wavelength, then it has high frequency. High frequency. Frequency is very high for violet lights, and for red light there is a less frequency. Low frequency, or you can say there is less frequency. Frequency is very less. For violet light, the frequency is very high, and wavelength will be short. And they will bend according to the refractive index. The refractive index of the material is associated with the wavelength of the light. So that's why they will bend like this. And the violet light has to has to move a longer distance than the red. Since it is bending, the violet light will take much time to cross this region, but the red light will take time which is less than which is taken by violet light. Because violet is bending more, red is bending less. So this is the explanation by Newton the dispersion. So dispersion means it is the splitting of white light into its component colors. So this process is called as a dispersion.